Friends, welcome to ADSR Mathematics, NBHM 2012 PhD. Let capital A belongs to M3R, which is not the diagonal matrix. Pick out the cases where A is a diagonalizable over R. A is diagonalizable over R. Option A square equal to A when A minus 3I whole to the power 2 equal to null matrix, when A square plus identity equal to null matrix. Here A is a matrix of order 3 cross 3. A belongs to M3R. This means all entries of A are from real, and this is the order of A be 3. Now, and another condition is given that A is not diagonal matrix. That means only the diagonal element be the remaining element except diagonal be not all 0. So in that hypothesis, which of the following options will be true? First option given that when A square equal to A, if A square equal to A, then we get the annihilating polynomial b x square minus x. We get the annihilating polynomial b x square minus x. And if we factorize that, then we get x into x minus 1. Now, in that case, the minimal polynomial, max equal to either x or x minus 1 or x into x minus 1. So, for the first case, A equal to 0, that means A is a null matrix. And we always know that in every null matrix is a diagonal matrix, but here given that A is not a diagonal matrix, so this case will not be possible. For in that case, the minimal polynomial if x minus 1, then we have A minus identity equal to 0, that means A equal to nothing but a identity matrix, and in that case also A be a diagonal matrix. So this is not possible for the given hypothesis, because here given that it is not diagonal, so it is also not possible. So only possibility are remaining, that means the minimal polynomial of the matrix A is x into x minus 1, and we know that the result, if a matrix be diagonalizable, then if and only if its minimal polynomial contains distinct linear factor. If and only if its minimal polynomial contains distinct linear factor, and here we see that this is a factor and this is a linear factor, both are distinct and both are linear. So only possibility of this matrix be max equal to x into x minus 1. So the matrix, if the condition satisfies square equal to A, then it is also diagonalizable. So option A will be correct. Now we comes to the second option. And another thing is that this is the condition only for idempotent matrix, and we all know that the idempotent matrix is always diagonalizable, and always diagonalizable over R as well as diagonalizable over C. So this for the matrix for this condition is also diagonalizable. Now it comes to the second option. Second option tells that when A minus 3 into identity whole square equal to null matrix, in that case the annihilating polynomial will be x minus 3 whole to the power 2. So the corresponding minimal polynomial of that matrix be either x minus 3 or x minus 3 whole square. If we take the possibility x minus 3, then we get A minus 3 into identity equal to 0, and hence we get A equal to 3 into identity. That means 3 multiple of identity matrix, and this again, in this case again A become a diagonal matrix, and here given that A is not diagonal matrix, so this case is not possible. So only possibility is x minus 3 whole square for the minimal polynomial of this matrix. So since the minimal polynomial of this matrix not contain distinct linear factor, here A is a one factor of power 2, so it is not linear, and by the previous result of the diagonalizability of a matrix about its minimal polynomial, So we can tell that the matrix which satisfy this condition is not diagonalizable. So for the option B, the matrix B not diagonalizable. Comes to the third option. The third option tells that the matrix satisfies the condition A square plus identity. In this case, the annihilating polynomial B given by x square plus 1. That means if we factorize this, we get x minus iota into x plus iota. So the minimal polynomial of this matrix B, only possibility this, because I cannot take only one factor, because we all know that the every polynomial function, every roots of the polynomial, every complex roots of the polynomial are exist in its conjugate. So if I be a roots of the polynomial, then minus I also a roots of the polynomial. So in that case, the minimal polynomial is exactly x minus iota into x plus iota, and here this matrix be diagonalizable over R by the previous result, that the matrix be diagonalizable since it contains the distinct linear factor. But here the roots of the minimal polynomial be iota and minus iota. This does not belong to real. So we cannot tell that the matrix be diagonalizable over R. But here he want to know that which matrix be diagonalizable over R. In that case, the matrix diagonalizable over C. So we cannot tell that in this condition the matrix diagonalizable over R. So this is also a wrong option. So only first option will be true, and but the remaining option will be incorrect. So thank you friends, thank you for watching. If you new to my channel, please subscribe my channel, tap to the bell icon, and please comment, share, like my videos, and if you have any doubt, please comment in the comment box. Thank you friends, thank you for watching.